Welcome back to our channel. In today's video we are going to discuss about input buffering. Here input buffering, the data will be stored in hard disk. Input buffering is read program part character by character. Okay, lexical analysis will take 25 to 30% of the compile time. Usually scanner, that means lexical analyzer, uses look ahead with double buffering to minimize the overhead. Okay, it means one buffer can be reading and another buffer can be loading. So here for example we can take int main function. Okay, here we have stored the overall program in a tape that are divided into cells. Okay, each and everything is considered as a token. Okay, in this, input buffering is used to read a block of characters from buffer using one system call. In this we have 100 characters but we need only one system call. Okay, here we have two types of buffers, one buffer and two buffer. Here in one buffer we use only one buffer to read the input string. That means size of buffer is equals to n characters. Okay, we have size of buffer n characters. Okay, that means for example we can take int I is equal to I plus 1 j plus plus. This overall data will be stored only in single buffer. Okay, this overall data will be stored in single buffer. That means we can see here in a single buffer each and every variable is stored in a one cell. Okay, each and everything which we have written in the program will be stored in a buffer. Okay, that means we have taken for the starting buffer fp, that means forward pointer, and bp, that means the begin pointer. eof is nothing but end of the buffer, file buffer. Okay, end of the file or end of the file buffer. See, here we have stored everything in a buffer. See, I is equal to I plus 1 semicolon, j is equal to j plus plus, and end of the file buffer. Okay, everything is stored in a single buffer, whereas in two buffer, the two buffer is used to reduce the complexity. Okay, it is used to reduce the complexity. For example, int I is equal to I plus 1, j is equal to j plus plus. Here we will have two buffers because to reduce the complexity we are using two buffers. In one buffer we are using only one buffer for the entire program. So the complexity will be high. To reduce that complexity we are using two buffer. Okay, here see. For example, in first buffer we are taking I is equal to I plus 1. Okay, so int I is equal to I plus 1. So this bp is the begin pointer and fp's are the forward pointers. Okay, one pointer after the another pointer. So every cell will be written as fp only, that is a forward pointer. Okay, and first cell will be written as bp, that is a begin pointer, and last cell in the buffer will be considered as eof, that means end of the file buffer. Okay, and in the second buffer we are taking j is equal to j plus plus semicolon. Okay, to reduce the complexity we are taking two buffer. Okay, for example here we can see then an algorithm for the input buffering. Okay, here we can see the algorithm for the input buffering. In if condition we are taking forward pointer is at end of the first buffer. Okay, forward pointer is at the end of the first buffer. So forward is equals to begin of the second end buffer. That means forward is equals to begin. Okay, begin of second buffer. Okay, and refill the second buffer. Okay, and refill the second buffer. If else forward pointer is at end of the second buffer. Here we are taking end of the first buffer and here we are taking end of the second buffer. Okay, forward is equal to begin of first buffer. Okay, forward is equal to begin of first buffer, refill first buffer. Okay, here we are doing refilling second buffer. In if else condition we are refilling the first buffer. Okay, and again the return statement. Okay, this is the algorithm for input buffering, or we can call it as the code for input buffering. Okay, thank you.